Hi everyone, I welcome you all to my YouTube channel. So before starting today's lecture, I will suggest you to watch my previous lecture on differential equation. So anyway, we can start our today's topic, homogeneous and linear differential equation. So first of all, let me tell you about homogeneous differential equation. So definition says, if each term of the differential equation contains derivative that is dy by dx, or dependent variable that is dv, dependent variable, or function of dependent variable, then the differential equation will be said homogeneous differential equation. If you want to write the definition, then you can write, if each term in the differential equation contains derivative or dependent variable or function of dependent variable. Function of dependent variable like y is a function of y itself, or sin y, like that, etc. These are function of dependent variable. Then the differential equation will be said as homogeneous differential equation. So otherwise it will be told as non-homogeneous differential equation. For example, d2y dx square plus 2 dy dx plus y equal to 0. Here you can see each term contains either derivative, here it is derivative, here it is derivative, and here it is dependent variable. So it is a homogeneous differential equation. One more example, dy by dx plus y equal to sin x. Here you can see this is derivative of dependent variable, it's okay. Here it is dependent variable, but here doesn't contain either derivative of dependent variable or the dependent variable. It is independent variable. Okay, sin x is a function of independent variable x, so it is not a homogeneous differential equation. So I hope you understood the concept of homogeneous differential equation. Okay, so let me take you to the next topic, that is, it is done. Next topic is linear differential equation. So linear differential equation. Okay, so in order to check whether the given differential equation is linear or not, we have to set 4 different conditions. So I want to write these 4 different conditions, then it will be clear to you. So first point is that the degree of dependent variable dv, that is dependent variable, the degree of dependent variable is 1. Condition number 2, the degree of differential equation is 1. Number 3, the dependent variable and its derivative, dependent variable and its derivative are not multiplied. I hope you are writing along with me, because this condition will be implemented in my next example, so better you write along with me. So number 4 condition is transcendental function transcendental function. I will tell you what is transcendental function. Transcendental function doesn't contain dependent variable. Okay, these all are 4 conditions that must be satisfied in order to consider a differential equation as a linear differential equation. Okay, so these are the conditions. So example number 1. Example 1. So suppose d2y dx square plus y by 2 dy dx equal to 0. So here you can see order of the differential equation will be what? 2. If you watch my previous lecture, then you can tell me that order of the differential equation is 2, because highest order derivative is 2. Degree will be 1, because power of this highest order derivative is 1. So degree is 1. Next we have to check whether it is homogeneous or non-homogeneous. So there are 2 terms in the differential equation. Here it is the derivative of y with respect to x. Here it is derivative again, and it is multiplied with dependent variable. So each term containing dependent variable, so it is homogeneous. So it is homogeneous. Next we have to see whether it is linear or non-linear. So to check linear or non-linear, we must check this condition 1, 2, 3, 4. So 1, the degree of dependent variable is 1. So here you can see degree of dependent variable is 1. So number 1 condition is satisfied. Secondly, the degree of differential equation is 1. Here you can see the degree is 1. I already mentioned. So number 2 condition is satisfied. Number 3 is that the dependent variable and its derivative are not multiplied. Here you can see the derivative is this and dependent variable is this. So dependent variable and derivative are multiplied together, right? So number 3 condition is not satisfied. So this implies it is non-linear. I hope you are understanding. Okay, so let me give you another example, number 2. So suppose d2y dx square plus dy dx plus sin y equal to 0. Okay, so here you can see order will be what? Order will be simply 2. If you are not understanding, please watch my previous lecture. Order is 2. And degree will be 1, right? Why degree is 1? Degree is 1 because highest order derivative is 2, right? And power of this term is 1. Okay, so degree will be 1, right? No, that is wrong. If you did watch my previous lecture, then you can see the differential equation must be capable of expressing as a polynomial. Here is dependent variable is function of transcendental function. So degree is not defined. Degree is not defined. Here order is 2. Okay. Then is it homogeneous or non-homogeneous? Here you can see each term containing dependent variable. It is dependent variable. Actually it is a function of dependent variable sin y. It is derivative of dependent variable. Again it is derivative of dependent variable. So it is homogeneous. Homogeneous, right? So next we have to check whether it is linear or non-linear. Okay, to check linear or non-linear, first we have to check the first condition. The degree of dependent variable is 1. Yes, degree of dependent variable is 1. here there is no single dependent variable, so we can take 1 is okay. So number 2, the degree of differential equation is 1. Here it is not defined, but you can see it is not more than 1. We can say it is not more than 1 because the degree of differential equation, if it is not there, then it will be 1 only. So power of the highest order derivative is 1. So 2 is satisfied. Okay. And number 3 is that the dependent variable and its derivative are not multiplied. Here you can see there is no such condition where dependent variable and derivative are multiplied. So number 3 is satisfied. And number 4, here it is said transcendental function doesn't contain dependent variable. Here you can see y is dependent variable and sine is a transcendental function. Transcendental function are those which are sine, cos, logarithmic function or natural log, like sine function, cos function, tan function, log function, ln function, like that. These are transcendental function. Here dependent variable is sine function is a function of dependent variable. So number 4 is not satisfied. So it is non-linear. Okay. So that's all for today. I hope you understood my point regarding linear differential equation as well as homogeneous differential equation. So next lecture will be on method of separation of variable. So this is the first method of separation of variable to solve differential equation. Okay. So I hope you understood all. So stay tuned for my next lecture. Thank you.